Hello everyone, welcome to our presentation on our work titled Towards Better Characterization or Paraphrases, jointly authored by me and my advisor, Professor So Wen. I'm Timothy. I'm a PhD student at the Singapore University of Technology and Design. Thanks for attending this talk. In this talk, we will outline our work, right, starting off from what is a paraphrase, right, to better set the sort of context. And then for us to better understand the motivation of this work, we will talk about why we want to better understand paraphrases. We will then introduce two new metrics for understanding paraphrases: word position deviation and lexical deviation. And lastly, we will show the application of these two new metrics, right, to better understand paraphrase datasets, improve datasets like MRPC, and also we demonstrate that we can basically filter and rank outputs from paraphrase generation models. So firstly, what's a paraphrase? Right, so we are going to talk a bit about this because it's quite interesting that there are a few different definitions. Right, so the main definition that we're going to follow is that basically a paraphrase is a paraphrase of another sentence if they are not identical but they share the same meaning. Right, so this is I guess is a pretty common definition of paraphrase. Right, there are other definitions. Right, some are a bit more strict, like for example, both paraphrases must mutually entail each other. Right, and then there are some which are a little bit different, right? They are from maybe other different kind of contexts, like maybe from an English language kind of course, right? That they will say that a paraphrase is you reword a sentence to make the meaning clearer. So in our case, we don't really want the meaning to change, right? So I'll talk a bit more about this later. So now to our motivation, right? Why do we want to better understand paraphrases? So firstly is we want to basically create new methods for robustness testing of NLP models, right? So currently most of the robustness testing is via different kinds of perturbations, right? Like we change a character, we change a word and so on, right? But majority of the perturbations can actually inadvertently change the meaning of a sentence, right? Because usually it's not constrained. Therefore, when we actually try to constrain the meaning and the quality of the perturbed sentence, right, in terms of like the grammatical quality, right, making sure the meaning is the same and making sure the sentence doesn't look like weird, like a not natural sentence, right, the effectiveness of the attacks usually drop quite dramatically, right? So for example, textfuller actually drops from about 91% attack success to about 11%, right? And then when we look at what textfuller actually generates, right, on like different kind of samples, we will see that usually it generates a somewhat weird looking sentence, right, by replacing words that are nearby in the embedding space, but the output sentence looks a bit weird. And if you were to give someone like passing by on the street these two sentences, right, he'll tell you that probably the second one looks a bit weirder and I'm not very sure what it's trying to say, right? So newer methods can replace words with a little bit more appropriate alternatives, but because they still operate based on the same underlying principles where, I'm just searching for a word, then I replace it with a word in the embedding space, right? It still faces similar issues. So what we really want to do is that if you want to test the robustness of a model at classifying a piece of text, right, rather than just randomly perturbing the text, I will want to paraphrase the text so that I can test based on this sentence that has the same meaning to like people, right? Would the model be able to classify it the same way rather than just a random perturbation of the text? So therefore, we want to constrain the meaning and the quality of paraphrases. And also, if we do this as a sentence level kind of paraphrasing, we can generate more different diverse kinds of like robustness testing examples. However, one key issue over here is that we actually lack good measures of like what are the differences between different kinds of paraphrases, right? So of course, we know that one sentence can be paraphrased in multiple different ways. So how do we quantify these differences, right? And ideally, the metrics we use to quantify should correlate to like some human perceptions of the text. So existing metrics such as the blue rogue score, as well as like certain derivatives like self-blue, which are very commonly used, don't really tell us a lot about what are the differences between different paraphrases, and neither do another common way to measure differences in text, which is the various kinds of edit distance, also don't really tell us a lot. Therefore, we want to come up with metrics that can answer like example all these kind of questions, right? So what is the method being used to paraphrase a sentence? What's the difference between different paraphrases from different data sets, and if we have different paraphrase generation models, how do we compare the differences between the different paraphrases? Therefore, we introduce our two new metrics, right? The first one is word position deviation, which measures the degrees of structural changes between paraphrases, and lexical deviation, which measures the degree of lexical changes or vocabulary changes between paraphrases. So with this, we measure two of the main mechanisms used to achieve paraphrasing, right? The first one is to structurally alter the sentence, and the second one is to basically change the vocabulary being used in the sentence. So we move on to word position deviation. So essentially what we're trying to do is we're trying to measure how every word's position changes between each of the paraphrases. So for example, you will see over here that the word his, right, basically shifts roughly about half the length of the sentence, right, when it's being paraphrased. So of course there are a lot of different edge cases, like for example, what if there's multiple his over here, right? So basically in this case, we take the maximum of the relative word shift, right, as the position shift of that word itself. And then when we take the average of all the different kinds of words, right, we will basically get the WPD score, which we see that is actually a quite a good way to measure structurally how different sentences are. So next is lexical deviation, which is a relatively simpler measurement, right? So basically what we're doing is we're measuring the degree of overlap between the vocabulary being used in like the two different sentences. So now how do we apply WPD and LD, right? We can apply them in various different methods, right? So we can use it to search for specific types of paraphrases. We can use it to compare the properties of different data sets, and then we can use it to also filter and order the output of paraphrase generation models. So we start off by trying to do a comparison between MRPC and PAWS, right, which is another high quality paraphrase dataset, right? So we can see that MRPC actually differs from PAWS quite dramatically here. It contains a lot of lexical diversity because the overall LD scores are too high, and in fact we actually noticed that like there's a large chunk of the paraphrases actually have more than half of the words between the two sentences not overlapping. So logically it's actually might be a bit too much. So we actually do investigate this further later, right? But you can see that for PAWS, because of the way it's collected, the lexical deviation is actually very low, like mostly less than 0.2, with a lot of sentences having basically no lexical changes. So with WPD, we see that generally both of the datasets are quite similar in the sense that most of the sentences don't really have a lot of structural changes, right? So if you want to train a model to generate structurally diverse sentences, maybe we can filter the dataset and take the sentences that have a higher WPD, right, in order to let our model train how to generate structurally diverse sentences. So next, we can also demonstrate that we can use this to search for specific types of paraphrases. For example, a paraphrase that has very little lexical changes and large structural changes. So for this, I actually have a demo over here, right? So the URL is linked in the GitHub repo, right? So for example, this is the MRPC dataset. I want to filter by very little lexical changes, so I can set the range of the LD to be lower, and then I can set the range of the WPD to be higher in order to basically search for paraphrases that change a lot structurally. So what we see over here is that, right, so Nancy Reagan is saying something to Fox News, right, and then the quote is in the front. When the quote has been shifted to the back, right, and then Nancy Reagan issue a statement has been shifted to the front, we see that the WPD is very high, right, above 0.45. So this is the kind of things that we can measure with WPD. So moving on, we investigate basically why MRPC has a high lexical deviation. We find that a lot of times the pairs with high lexical deviation actually have inconsistent entities, right, which is the result of which results in the words not overlapping because the entities like the people mentioned, the quantities mentioned, they basically don't line up, and therefore these really aren't paraphrases. So based on this idea, right, that basically a lot of entities in MRPC are inconsistent, right, we actually propose an automated procedure to search for paraphrase pairs that have these inconsistent entities and then correct them. So we do things like correcting the date and correcting the figures, right? So we are able to, for example, fix the inconsistency in the paraphrasing, right? And then after that, for those paraphrases that we're unable to fix, maybe because the numbers or entities are not the same, so there's literally no way to fix it, right? We relabel them as non-paraphrases, right? So we fix about 16% of the original inconsistent pairs, and then we relabel the rest. And then what we basically do is we propose this as a revision of the MRPC dataset. We term it as MRPC R1, and then we can basically show that this dataset, when you train a model on it, right, not only does it transfer better to other datasets such as PAWS, larger models also perform better, whereas previously with MRPC, larger models actually overfit, right? So therefore, we can see that actually we improve the quality of the MRPC dataset. So even though the transfer performance, right, is not really that amazing, right, it is a huge improvement from before, and therefore this is a higher quality dataset that if we combine it with other paraphrase generation datasets, it probably augments the training data a lot better than the original MRPC. Lastly, we can of course make use of the same method to filter, right? So for example, with a paraphrase generation model, then we use it to generate a bunch of different paraphrases of the same sentence. We can make use of WPD and LD to rank it in a specific way. For example, we can rank paraphrases in order of increasing syntactic changes, right? And then we use this for robustness testing, and maybe we can figure out that the model is not robust above a certain level of structural paraphrasing. So with that, that was outline of our paper, right? So we proposed two different new metrics, right? We show that they can be used for various different useful and interesting use cases, and we also propose a new revision of the MRPC dataset that actually generalizes better, right? So if you want to find out more about our work, you can go to the link at the bottom over here, which goes to our GitHub repository. So thank you.